So let's go over to 2008 multiple choice, AP multiple choice, with the calculator. So we're just gonna do the final 15 with the calculator. So the thing about this like air quotes with the calculator is that they don't all need a calculator. See, about half of them generally need a calculator, the other half you do easily without it. Much like the first one right here. The graph of f prime is given, the derivative of f is shown above. So this is the graph of f prime. That's very important. You want to know what graph you're talking about. So we're talking about f prime. On what intervals of f is f increasing? So this one's actually a pretty straightforward one. If you're given the graph of f prime, remember what f prime tells you. F prime tells you that if f prime is positive, that f is increasing. F prime is negative, f is decreasing. Look what the question is asking for us. When is f increasing? So I'm just looking for where the derivative is positive. I have the derivative, so I just want to know where it's positive at. So here and here. So I'll tell you right now, I would have answered this as -2 to 1, union 1 to 3. That's actually not one of these options here. And what they did was they just went the whole top here, -2 to 3. So I guess it doesn't actually touch down. So B. All right, you got to be able to find the one that works best for your answer there. That was clearly the best answer. Moving on to the next one. It's another one that doesn't need a calculator, and it's actually honestly fairly easy. The figure above shows the graph of the function f with domain from 0 to 4. Which of the following statements is true? The limit as x approaches 2 from the left. Remember, the little minus sign there means from the left exists. So 2 from the left, that's this side, you're coming from the left. It's an open circle. That does not matter. Limits don't care about open or closed. They don't care what happens at the actual line. They just care as you get close to the line, what happens. So essentially, anytime you do a one-sided limit, it always exists. Right? When would it not? If I did like an edge here, if I said what's the right side limit of 4, well, there's no right side, so it doesn't exist. Technically, if you get infinity, then you could say infinity, which is not technically a number, so you could say it does not exist also, but most of the time they use infinity, negative infinity. But in general, left and right limit should always exist. So the left limit from here does exist. It's whatever number this is right here. The limit from the right exists. Well, the limit from the right would be this number, whatever that value is. So that's true also. The limit exists. Now remember, for this to be true, these both have to match, and they do not match. So this is false. So only 1 and 2 are true. So C. The next one. Finally, one we can do in our calculator. The first derivative function f is defined by this. So this is my derivative. On what intervals is f increasing? So kind of like the first problem, but without a graph. So you know what we do? We graph this on our calculator. If you put this in our calculator, make sure you fix your window. You want to make sure you're in radians. If you want to graph this, fix your window. And since we're looking for f is increasing, we're looking for f increasing just means where the derivative is positive. So essentially the first question just would do it ourselves on the calculator. So bring out your calculator. I was doing stuff from a different class. Make sure you're in radians. There we go. I'm going to go to y equals. I'm going to type that in. And it's very important here to be in radians because we're actually doing sine. It only really matters when you do trig functions. This, by default, we always use radians. So sine of x cubed minus x. Come on, go down. Minus x, parentheses, there we go. Now before I graph, I'm going to change my window from 0 to 2. So my x should go from 0 to 2. I might have to change my y. Honestly, it's probably a little too small because I should probably go from 1 to 1. That's my amp. But we'll see how it looks. And that looks kind of disgusting. I'm going to put zoom fit just to show you. When you go zoom fit, it does not affect the x values. It only affects the y values. So try to find a nice graph for you in the y's. Sometimes it doesn't work. I think most of the time it does. So again, it won't change the x values. It'll only change the y values. So we want to know where it's increased. So I got to find it from here to there. So second trace, I'm going to find the zeros. So I'm going to find, ooh, how nice. I'm going to go a little left of there, a little right of there. And I get 1. So look at your options. All these are gone. It's between these two guys. But I still got to find it. So second trace, 0. So you got to keep on moving until you get all the way over there. Now, I actually don't have to find it. It looks like it's around 1.6. It's not around there. So I know it's B. If you want to double check, you can find it. But in this case, it's far enough along, I could kind of just tell by getting close to it. And 1.69. So it is this one. It's B. So there we go. Next one. Oh, this is a joke. If the integral from -5 to 2 of f of x equals -17, and the integral from 5 to 2 of f of x equals -4, what's the value of -5 to 5? These are some of my favorite questions. Right, we gotta add these two, we gotta combine these two integrals to get that integral. So like I always do, right, start down here. Start with -5. What does -5 go to? -5 goes to 2. And that has a value, I wrote way too big. Let's start down here like this. -5 goes to 2. And it has a value of -17. Now if I want to add an integral, right, remember that 2 there has to be in the bottom. The only way to add integrals is that these two match. So if I have a 2 in the bottom, the top has to be, what's on integral to 2? This guy right here. But I got to flip it. So it goes 2 to 5 of f of x. But since I flipped it, that's not a -4, it's a +4. And then that's how you add integrals. So when I add these up, I'm going to get from -5 to 5. And on the bottom, I get -17 plus 4 because I just flip it, which gets me -13. So B. 80. The derivative of the function f is given by this x squared cosine x squared. How many points of inflection does the graph of f have on the open interval -2 to 2? So a couple things going on here, right? They're asking about points of inflection. So you got to first remember how do you get points of inflection. It's when the second derivative equals 0 plus the sign change. 0 undefined plus sign change. Now I have the first derivative. So you have a couple options here. You could graph the first derivative and then find all the points of inflection. We'll talk about how to do that. Or you could graph the derivative of this and just find the zeros plus the sign change. It's kind of up to you. It's generally a little easier just to graph the function you're given, so you don't have to like worry about taking a derivative of it. You know, you can, but it's just a little. You can do it all in your calculator, but it's just a little smoother, a little less funky. You just graph the derivative they give you. So x squared cosine x squared, and very important I'm in radians because all trig functions all around. I'm gonna change my window one more time. So now I'm going from -2 to 2, not 0 to 2. Like that. I'll put the zoom fit again, which is 0, I believe, to see how it graphs it for me. So I get something like this. Now, so this is from -2 to 2. Keep in mind it says how many, not find them. It says how many. And then also keep in mind that we're on the first derivative. So I'm not looking for the zeros. If I'm on the first derivative, how do I find the zeros of the next function? That's what we gotta think, right? How do I find the zeros of the next function? If you remember, it's when you find the min and max points, right? So if I have f prime, and I want to find where f double prime equals 0, it's the min and max points. It can be your zeros. So how many min and max points do I have? I have 1, 2, 3, 4, 5. So E. And that's it, right? So keep in mind, again, I have the first derivative. I'm trying to look for the zeros of the next derivative. I'm looking for the zeros of the derivative of that. So I need the max and midpoints. And they all change signs if you're wondering. It goes from negative slope, or slope change, you can think about it that way. Right? It goes from negative slope to positive slope, positive negative, negative positive, all sign changes. So there's 5. That's the answer. The next one is a little funky, but it's not that bad if you remember the rule I was trying to teach you. G is the antiderivative of f. So that's just a fancy way of saying G equals the integral of f. That's all that's saying. Is the antiderivative of f. And G of 2 equals -7, and G of 4 equals what? So I always talk about this. If you have the integral, if you have a function, you're trying to find like the integral of it, but you don't actually have the values, what you do is this formula, right? If I'm trying to find like f of 3, it's the initial value plus integral of the derivative of 3 from the initial value to 3. Like that was always the rule, right? If you're trying to find a function and all you have its derivative, you integrate the derivative plus the initial value. So that's what's going on here. I'm trying to find G of 4. So it's going to be the initial value plus the integral of my derivative, which is f. That's all. That's another way of saying that also. And then again, I'm going to 4. So what's the initial value they gave me? They gave me this. Now, x is the 2 and the y is -7. So 2 goes here and 7 goes there. So my answer is going to be G of 4 equals -7 plus the integral from 2 to 4 of f of x. So that's the idea. So that's just something that happens. Anytime you have, like, you have a derivative, that's what f is. That's another way of saying that too. F is a derivative of g. You can tell that if I take a derivative here, you get just f. Right, so if you have the derivative, and you're trying to get the original function, you integrate it and you have the initial value. What's my initial value? G of 2 equals -7. So 2's the x value, and then the initial value is actually 7, and then you're going to 4, so 2 to 4. I feel that I explained that very well. Well, anyway, next one. A particle moves along a straight line with velocity given by 7 minus 1.01 negative t squared at time t is greater than 0. What's the acceleration of the particle at t equals 3? Well, how do you go from velocity to acceleration? You take the derivative, right? Because it goes sva. So right here, we want to go down to acceleration. So you take a derivative. We can do this on our calculator. I think the easiest way to do it, so you make sure you don't mess up, would be I would put it for y1. So for y1, I'll type in my velocity here. So I go 7 minus 1.01 to the, again, we don't have t, so let's use x, to the negative x squared. So it's all typed in. Now I'll take a derivative of that. So I'm going to get out. I'm going to go math derivative, which is number 8, and derivative. I'm going to just put x, so the only variable we have. And then I'm going to type that equation there, right? So I'm going to put, instead of typing it in, I'm going to press alpha F4 and get my y1. That way I know for sure I didn't mess anything up. I want this at 3. I get 0.0548. Rounded is this one. So we get b here. So there we go. Next one. What is the area enclosed by the curves of y equals x cubed blah 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 and y equals x plus 5? Well, gonna have to graph it. So this one, you definitely need a calculator on this one, and the last one too. Let's see, so let's graph these. So go y equals, type them in, x cubed minus 8x squared plus 18x minus 5. Whoops. And then x plus 5. Now in this case, I'm actually going to go back to Zoom standard because I don't have a window to work with. So I'm just going to go back to the standard Zoom and see what it looks like. So Zoom 6 standard view. And I get something like that. I might want to zoom in a bit. Maybe look at the first quadrant. Now because remember, it's the area enclosed by the graph. So it looks like it's enclosed right there in this part. So let me change it myself. I'm going to go from like 0 to like 15 maybe. And then I would also go from 0 to like 15. See if that gives me a little better graph. So I can play with it a little more. There we go. So the enclosed area looks like these two. So I kind of have a graph that looks like this. Right, so I'm looking for these two guys. So first I gotta find all the intersections, because this is actually two integrals. Let's set up what we have already, right? So this is gonna be an integral. This is y1 and y2. Let's call it, I don't like that. I mean, it is y1 and y2. Let's say f and g, just for the sake of it. So look at this integral right here, right? What's the one on top? It's a cube graph. This is the one that's on top on this guy. So that's f. So this will be the integral of f minus g dx plus the integral over here, the lines on top, so that's g minus f dx. Now I gotta find the limits. So I gotta find those limits. That's what I'm gonna do next. So my calculator is find the intersection. So the first curve, where am I at? So again, I can't really see where I'm at right now, but this tells me it's at 6. So I'm probably around here, or 6 is. Go moving, or you press up to look at the other guy. Oh, so there I'm at. So let's just find this one here. I'm right here. Let's find that one anyway. So enter, enter, enter. I get 5. How nice. So this is 5. That's my last endpoint. Are they all gonna be that nice? Second trace. Let's press 5 this time. Find the intersection. Now let's get closer to this guy. And I get 2. How lucky. So far I don't have to store anything. This next one would be 1. Intersection. Next one. There we go. Enter, enter, enter. -1. How nice. So that's my integral. So we're going to set that up. This way I set it. So we're going to go math 9 for integration. I'm going to go from 1 to 2. It's just done y1 minus y2. So f is y1. So alpha calculator y1 minus alpha calculator y2. And then x plus math 9. We're going 2 to 5. And we're just going to switch it around. So alpha calculator y2 minus alpha calculator y1. Close it, and then x. Hit enter. Let it think. 11.8. So B. Okay, let's move on. So 84, the graph of the derivative function f is shown above. So again, this is a derivative, very important. The graph has horizontal tangent lines at -1, 1, and 3. So -1, 1, and 3. At which the following x values does f have a relative maximum? So relative max, we gotta first figure out what they are. Where the relative max is just a critical point. How do you find critical points? It's where the derivative equals 0. Right, so where the derivative equals 0, that's a critical point, and relative max is a critical point. Specifically, it's a critical point where you go from positive to negative. Right, when it looks like this. You go from negative to positive, it's a min. So I have the derivative here. So how do you find the critical points? It's where it equals 0. So my critical points are here, here, and here. Which of these is the relative max? Well, this one goes from negative to positive, so that's actually a min. This one goes from positive to positive, so it's a neither. And then right here it goes from positive to negative. So that's my relative max. It's at 4. So C. 4 only. Next one. Table gives values of the function f and its derivative at selected values of x. So here's f, and here's f prime of x. If f prime is continuous on an interval of -4 to 1, what is the value of f of -4 f prime dx? So it's continuous, that's great, so that means we can't integrate this. So how do you integrate this, right? What's the integral of f prime? Integral of f prime is just f. Then you're going for your limits, -4 to -1. So plug it in. Remember the way you evaluate integral, it's top minus bottom. So f of -1 minus f of -4. Now what's f of -1? Look at our table. F of -1 is -1.5. F of -4, look at our table. F of -4 is 0.75. Now we have a calculator, plug it in, or we can just do the math. You get -2.25. So B. That's all it is, right? Integrate this. Obviously, integrate f prime, you get f from your limits, -4 to -1, bring it down, get your answer. Next one, 86. The table gives selected values of velocity of a particle moving along the x-axis. At time t equals 0, the particle is at its origin. Which of the following could be the graph of the position function? So they give us this graph of the table and want us to find the position function. So this is a little weird. We have the derivative. We're trying to find the original function, but it's based off a table. So the best thing to do is kind of look for like key points. Right, so remember, this is a derivative, and this is like the function. So look at here. What happens when the derivative equals 0? Right here, at x equals 3, I guess t equals 3. Sorry again. There we go. Then we have a critical point. And it goes from positive to negative, so it really should be a max. So we should have a max at t equals 3. So look at A here. At 3, no max to be found. Look at B. At 3, that's a 0. That's not a max. That's probably just a graph of the function. C has a max, so C could be it. D does at 3 has a max. D has a max at 2, not 3. So it's not D either. E has a max also at 3. So it could be C or E. So we gotta decide between those two. So now we gotta look at, okay, what's the difference? They both are 0. This one has a little bit longer at 1. At 1 it's negative, and over here at 1 it's positive. So what does that mean? Well, if the derivative is negative, that means it's decreasing. If the derivative is positive, it should be increasing. So what's my derivative at 1? My derivative at 1 is 2. Right, so f prime, or I guess v of 1 equals 2, so I should be increasing. S, or f, should be increasing. And look at this one, it's negative, so that's showing that's decreasing, this one's increasing. So my answer is C. '87. An object traveling in a straight line has position xt at time t. Its initial position is x equals 0, at x of 0 equals 2, and the velocity of the object is this. What's the position of the object at t equals 3? So it's actually very similar to the one we had earlier, where they give you the derivative, they want you to find the initial function, right? And I talked about this. If you have the derivative, you want to find the initial function, the easiest way to do it is this. So if you want to find s and you have v, is you integrate its initial value plus the integral of the derivative. So in this case, since we're trying to find a position function, we're going to add the initial value plus the integral velocity. What's my initial value? X of 0 equals 2. So I'm going to have 2 plus the integral from 0 of my velocity equation. And what am I looking for? T equals 3. So S of 3 equals the integral from 0 to 3. I guess it should have been X, but I'm like X. Anyway, we're going to plug this into our calculator. That's it. Right? Anytime you have a derivative, you try and find the initial function, all you have to do is integrate the derivative and add the initial value. The initial value is here, 2. I was looking for 3, so 3 goes up there. And where's my x value of the initial? 0. So it's got to type this in. 2 plus the integral, math 9. Integrate from 0 to 3. Normally I would put my graph under y1, but I'm fine putting that in there. So cube root. So you go, if you want to be sure, you go at math and find the cube root. Or you just put 1/3 power. And then 1 plus x squared. There we go. And x. Get my answer, 6.51. So D. 88. The radius of a sphere is decreasing at a rate of 2 centimeters per second. This sounds like a related rates question. So the radius of the sphere is decreasing at a rate of 2 centimeters per second. So a couple things going on there. Even before we do the rest, right? The radius is decreasing. That's a rate. So dr dt equals -2, because decreasing, -2 centimeters per second. At the instant when the radius of the sphere is 3 centimeters, so that's when r equals 3. What is the rate of change in square centimeters per second of the surface area? So they want to find dA dt. Right, so they gave me the rate. They want to find dA dt. What they want to find the rate of the surface area, right? What is the rate of the surface area? And then they give me the equation. So we have all that. Now, the general rule of this, you cannot plug in r until after you take a derivative. So r is going to stay there for now. So how do I do this? Well, I'm on dA dt. I guess I use s for surface area. So let me change my a to s. So ds dt, because they're using s for surface area. So this is the equation. I'm on ds dt, and I have dr dt. So just take a derivative with respect to t. So derivative with respect to t for both sides. The derivative of s is 1, but wrong variable. ds dt. This is all just a number. So what's the derivative of r? Derivative of r is 2r, but wrong variable. So dr dt. So that 4 pi stays there, and then I get 2r dr dt. And then we can plug stuff in. R is 3, and dr dt is -2. I can multiply all this together, but if you notice they're all in pi, so I can just do it by hand. I get 4 times 2 is 8, 8 times 3 is 24, 24 times -2 is -48. So -48 pi. So C. 89. The function f is continuous for -2 to 2. If f of -2 equals f of 2 equals 0, and f of -2 equals f of 2 equals 0. If there's no c where -2 to c is between -2 and 2 for which f of c equals 0, which of the following statements must be true? So this is like a MVT, IVT question. So the function is continuous from -2 to 2. So sometimes I like to draw it, so I have a picture in my head. So it's continuous from -2 to 2. So that means it could be like this. It could be, who knows? It could be nice, but it's continuous. It's one of those things. It's not separated. And f of -2 equals f of 2 equals 0. So we have this point here and this point there. If there's no c for which the derivative equals 0, which the following statements must be true. So this is a Rolle's theorem thing. If you remember Rolle's theorem, it says if f of a equals f of b, then, and you have to be continuous and differentiable. That's the key. Then, if f of a equals f of b, then the derivative must equal c at some point. Must equal 0 at some point. Now again, notice what it's saying. It's saying there is no c that makes this work. So something here has to be wrong. Now they tell us already it's continuous, so it can't be it's not continuous. It has to be it's not differentiable. That has to be what's wrong. Now what's going on here? Which the following statement is true. So between -2 f prime the derivative is positive. No, that doesn't matter. It has to be negative. No, again, same reason, doesn't matter. The derivative has to exist. Nope. We're talking about the derivative cannot exist, so no. The derivative exists, but it's not continuous. They already told us it's continuous, so it's not that one. A positive elimination better be C. For some k, there exists a value where the derivative does not exist. Yes, that's the one. So it's E. So again, it's a little funky. It's a funky one. It's a Rolle's theorem question, but they're saying, hey, the second part doesn't hold. If that doesn't hold, something must be wrong. Either it can't be continuous or can't be differentiable. They told us it was continuous, so it just couldn't be differentiable. So what's the one that's wrong here? The one that's not differentiable. I mean, what's the one that's correct here? The one that's not differentiable. Okay, 90. Oh, I don't like 90. The function f is continuous on the closed interval 2 to 4 and twice differentiable. So there's two derivatives on this guy. On the open interval 2 to 4, if f prime of 3 equals 2 and f double prime of x is less than 0 on the open interval 2 to 4, which of the following could be a table of values for f? I really don't like this one. Okay, let's break down what it means. So f prime of 3 equals 2. So that means that the derivative of f at 3 equals 2, so that generally means it's increasing. Now if you look at all these, they're all increasing, so that doesn't help me. Yay. If we go a little deeper though, since I have everything around 3, I could just say the slope of 3 equals 2. So we could check those out. Does the slope of these equal 2? So like, how do I find the slope of this? Well, if I'm trying to find the slope of 3, I'm going to go around 3. So I'm going to go 4. I'm going to go y2 minus y1 over x2 minus x1. Right? Here's my x's, here's my y. So let's go around 3. So it's like, you're trying to find like the average. So 6.5 minus 2.5 over 4 minus 2. And I would get 4 over 2, which is 2. So this one checks out. If I do it here, 7 minus 2.5 over 4 minus 2, I get 4.5 over 2. So that does not equal 2. So 2 b's out. Here I get 6.5 minus 3 over 4 minus 2. So I get 2.5 over 2. So that's also not 2. So C's out. Here I would get 7 minus 3 over 4 minus 2. That does give me 2. So that's still good. And then E, I think E works also. 7.5 minus 3.5 over 4 minus 2. That'll give me 4 over 2. So that also works. So we cut 2 out. We still have 3 left. So next, what's the next thing tell me? They tell me second derivative is less than 0. So that normally tells you concave down. That doesn't help me here though. What's concave down in this context? What else does it tell you? It tells you the derivative is decreasing. Remember, decreasing, just increasing, decreasing means the derivative you're talking about is positive or negative. So saying second derivative is less than 0 is the exact same thing as saying the first derivative is decreasing. Because remember, decreasing just means this guy is negative. The derivative of this guy is negative. So my derivative should be decreasing. My slope should be decreasing. So we have to find more slopes. So let's erase some of this. Again, I told you I don't like this one. Let's find the slope of these two and the slope of these two. See if it's decreasing. The slope of these two, I get, it's easy to do though. 5 minus 2.5. 5 minus 2.5 over 3 minus 2. So I get 2.5. Now, if this one should be good, this should be decreasing slope, should be less. So 6.5 minus 5 over 4 minus 3. So I get 1.5. So that checks the box so far. So far down, A looks good. Over here, let's look at these two slopes. So I'm going to get 5 minus 3 over 3 minus 2. So I get 2. I get 7 minus 5 over 4 minus 3. So I get 2. So that's a constant slope. That's like if the second derivative was equal to 0. It's a constant slope. So that's not it. I need a decreasing slope. Let's look at these two. 5 minus 3.5 over 3 minus 2. 1.5 over 1. So 1.5. 7.5 minus 5 over 4 minus 3. So I get 2.5. This one's actually increasing. This would be the second derivative greater than 0. So it's not these two either. So the answer is A. That's probably my least favorite question on this whole test. Next one. What is the average value of y equals cosine x over x squared plus x plus 2 on the closed interval negative 1 to 3? With the calculator, this couldn't be any easier. You just got to remember what's the average value formula. Average value formula is this. Integral from a to b of f of x times by 1 over the difference in the limits. That's the average value formula. So all I'm going to do here is put this in my calculator. 1 over 3 minus negative 1. Integral from negative 1 to 3 of cosine x over x squared plus x plus 2. That's it. So essentially put 1 over 4 times the integral of 1 over 3 of this guy, dx. Right? So let's bring back our calculator. So let's go 1 divided by 4 times the integral, math 9, negative 1 to 3 of, I need that fraction, alpha y equals, I'm putting fractions to be sure I put them there. Whoops. It's alpha y equals, I put second for some reason. And then cosine x. Close that parenthesis. This is why being rating is so important. We have like 4 or 5 like trig problems. Oops. Plus x plus 2. And then dx over here. There we go. My answer is 0.18295. So 0.183, C. Easy. Last one here. A city located beside the river has a rectangular boundary as shown in the figure above. So here's the river, here's the city, 4 and 7. The population density of the city at any point along a strip x miles from the river's edge is f of x person per square mile, which the following expression gives the population of the city. So this is kind of a weird one too. I like thinking about it like this. This is our population density function. We're not sure trying to figure out how populate it gets. And then we got a value of x. So this is our x, right? X could be anywhere from 0 to 4. And then this would be our population, f of x. So how do we find that whole area there? Well, we're going to integrate from 0 to 4 because we want to find the total amount. So our x goes from 0 to 4, we're going to integrate 0 to 4. Then what I'm going to do is get my function, integrate the function because that fills it all up. But since it's a 2D model, we know it has to be 7. So we're going to multiply this by 7 dx. And then you can pull out the constant, and you get 7 integral 0 to 4 f of x dx, which makes it B. There you go, and that's the worksheet.